Hi everybody, this is Barry Walsh, your COVID-19 Math 10 teacher, and today we are working in section 6.5 of our book, and we are doing linear equations, the slope point form, not to be confused with slope-intercept form. We'll distinguish between the two as we proceed. Let's look at graph number 1. So, as a review, I've decided that what we'll do first is slope-intercept form. This is what you're familiar with, so let's feel good about this before we do anything else. The nice thing about slope-intercept form and slope-point form is you still find the slope in exactly the same way. So in this particular case, we go to the y-axis, just as we'd done the previous two lessons. We see as the line is going up and to the right that it's going to the right 1 and up 2. So if we write down here y equals mx plus b, because that's the letter form of the slope-intercept method, let's put the y-intercept in first. We can read that right there. That's plus 1. And the slope is, the rise is 2, and the run is 1, so that would be 2 over 1x plus 1, which would be just y equals 2x plus 1. So that's what we've been doing all along, and that's just a quick review for you. Okay, so let's look at slope point form. I don't think you're going to find this difficult. It's just a little different. So the letter form of slope point form is y, take away y1, equals m times x, take away x1. Now on the graph, I've chosen the point 1, 3. So with 1, 3, remember the first letter is x, so this is going to be x1 and y1. Okay? So when we're going to transfer this down here, why don't I write it like this? 1, 3. X and y. So y, take away, what's y1? y1 is 3, so we put that there. What's the slope? We already worked out the slope, did we not? Yes, it's up here, it's 2. And x, take away x1. What's x1? 1. That's it. That is the point form of the equation. Not too bad. So once again, like the slope-intercept method, you have to identify x and y in the point you're working with. And I called this one x1, y1. Whatever point you're working with, that's going to be x1, y1. And you just plug it into the letter form of the equation. That's all there is to it. Okay, so let's look at number 2. I'm going to do this one a little differently. So I wanted to do slope point form first for this one. So slope point form, y take away y1, you're going to get used to this. You'll do it so many times that don't worry about it. Equals m times x minus x1. Now the point that I've chosen here is -1 and -2. So this is going to be x1 and this is going to be y1. Okay, let's figure out the slope here. The line is going up and to the right. So let's see what the run is here. It's going over 1, 2, 3, 4. So the run is 4. The rise is 1, 2, 3. So what's the slope? Rise over the run. Change in y over change in x. The slope is 3 over 4. And x minus and y minus. You can put a bracket here if you want to. Doesn't matter. It's much more important over here. I left out the bracket down here, but I put it in here. It doesn't matter with y. Okay, so if we take our x value is -1, so it's x subtract -1, and it's y subtract -2. Yes, so -2. So we don't usually leave subtract negative together like that. It's not a good idea. So what I'm going to do is I'm going to change it. You know what it's going to change to, don't you? Y plus 2 equals 3/4, and that's just going to be x plus 1. Now that's all there is to it, my friends. That's it. So it's less complicated writing it from the graph for this one than it will be for slope-intercept method. But we're going to do it. We have to do a little bit of work with fractions here. It's good practice. Okay, so let's write down the equation. Y plus 2 equals 3 over 4 times x plus 1. Now, what we have to do here is get y by itself on the left-hand side of the equation. So that means we have to get rid of the 2. Okay. So the way we did that before was y plus 2, opposite operation, remember? Y plus 2 minus 2 equals 3 over 4 x plus 1 minus 2. What happens to the plus 2 minus 2 on the left side? They cancel out. So we get y equals 3/4 times x plus 1 minus 2. Now when you have a number outside of a bracket with a variable, a letter in the bracket, we have to multiply, in this case the 3/4 times the x, and then we have to multiply the 3/4 times the 1. The -2 doesn't get multiplied because it's not inside the bracket. Okay, what is 3/4 times x? Well, it is 3/4 x. 3/4 times x is 3/4 x. What's 3/4 times 1? Well, anything multiplied by 1 is itself. So 3/4 times 1 is 3/4. And then I just bring down the 2. Now, we cannot add 3/4 and 3/4 x. Why? Because they are unlike terms. We cannot add -2 and 3/4 x because they are unlike terms. But what we can do is add these together. So that's what we're going to do. So I'm going to put 2 over 1. When you add or subtract fractions, you need a lowest common denominator. So the lowest common denominator would be 4. And what would we have to multiply by 1 to get 4 as a denominator? you were going to say 4, right? So we multiply the denominator by 4, and whatever you multiply the denominator by, you have to multiply the numerator by. Okay, that gives us y equals 3 over 4x plus 3 over 4 minus 8 over 4. Now remember, we're going to put these together because that's the whole idea of getting the common denominator, so we can put these two fractions together because they're like terms. Okay, so I'm going to come up here and I'm going to write this as my final answer. Y equals 3 over 4x. Now if you have minus 8 over 4 and plus 3 over 4, minus 8 plus 3 gives you minus 5 over 4. And that is your equation in slope-intercept form. Why was it harder than this one over here? Because it had a fraction in it. And we had to put two fractions together. But that's part of grade 10 math, being able to deal with that. So we'll look at some more questions. I'll be right back. Okay, so let's look now at question 3. Question 3 says, given the equation in slope point form, identify the slope and the point. So when we write y minus y1 equals m times x minus x1, the slope is the number that represents m, so it's just 2. So the slope is equal to 2. It's the number before the bracket with the x in it. So that's pretty simple. And the point on the graph, the x value of the point is with the x, and the y value of the point is with the y. However, we have to change the sign of the x number. I'll explain that in a minute. But we have to change the sign. So it's not minus 1 for x, it's 1. And it's not minus 3 for y, it's 3. Now this equation is from the first graph that we did, and if you look back at that, you'll see that the point on the graph is 1, 3. Okay, so let's look at the second example. So the slope in the second example is the m number, and the m number is 3/4. And this is the second graph that we did. So 3, that's a 3. 3 over 4. And the point is, the number with x is 1. We change the sign, get minus 1. The number with y is 2. We change the sign and get minus 2. And if you look back at the graph, that is the number on the graph, the coordinates of the number on the graph, minus 1, minus 2. Now for the third example, I actually put the graph here so you can see it a little better. So the slope of this one is negative 1/2. It comes before the bracket with the x in it, so that's minus 1/2. And the point is, go to the x number and you change the sign, so it's 2. And you go to the y number and you change the sign, it's minus 3. Now look down here at the graph that I drew for this one. Can you see that the point is actually 2 minus 3. So why do we change the signs? That's the question. So let's go up here and take a look. So if we have y minus y1 equals m times x minus x1, and the slope is minus 1/2, well, you can see here the slope is minus 1/2. It goes over 1, 2, and then it goes down 1. So this is 2 and minus 1. So the rise is minus 1 and the run is 2. So the slope is minus 1/2. And then it's x minus, and then it's, I'll use a bracket here, y minus. Okay, so if we're looking at the numbers on the graph, you see that it is x is plus 2, correct, and y is minus 3. So when the equation is in the subtraction form, these numbers are the same as the graph numbers. But of course, we don't like to have double signs in the equation, so we change the equation so we only have single numbers. So we have y plus 3, subtract negative is plus 3, and over here we're just going to have a single minus sign, so x minus 2. So here's the equation, and if I want to know the point, then I go to the x number and I change the sign, so it's 2, see? And we go to the y number and we change its sign, and it's minus 3. So that's why you change the signs. Okay. That's all the graphing we're going to do today. And I like to do these word problems, these practical applications, because they're very important, and I think you know that. Sometimes we don't like word problems, but they are an essential necessity. Okay, let me read this with you. Scientists have discovered that crickets chirp faster as the temperature rises. This is actually true, I didn't make this up. The table below provides information on the temperature in degrees Fahrenheit and the number of chirps per minute. Okay, so this will be x and this will be y. And let's get our ordered pairs here. If I can squeeze them in. So it's going to be 50 Fahrenheit and 70 Fahrenheit. So I'll just put 70 degrees here. And with 50 degrees Fahrenheit, we have 40 chirps per minute. And with 70 degrees Fahrenheit, we have 120 chirps per minute. So the crickets, you can see as the temperature goes up, they get more active. And that's the nature of insects. All right, so what we have to do, we have to get an equation. If we come down here, it says write the equation expressing the number of chirps per minute in terms of the temperature in degrees Fahrenheit. So when it doesn't ask you to write it in slope point form specifically or slope-intercept form specifically, you have the freedom to do it the way you want. And I'm going to use slope-intercept form. That's my favorite go-to method. You can do it the other way if you want to, but when the instructions say specifically to do it slope point form or specifically to do it slope-intercept form, then you have to follow those instructions or you will lose points. Okay, so the first thing I'm going to do is get the slope. Slope equals y2 minus y1 over x2 minus x1. And that is going to give me, so if I call this, I'll use another color, x1, y1, and x2, y2. So y2 is 120, right here, y2. It's important that you don't get these numbers mixed up. That's why I write on there x1, y1, x2, y2. So 120 take away y1, which is 40, over the x's on the bottom, 70 take away 50. Okay, let's work that out. We have nice round numbers here. 120 take away 40, that's 80. And for the denominator, 70 take away 50 is 20. And when we divide those, we get 4. So y equals mx plus b. So y is equal to 4x plus b. So now I have to choose one of these points. I'm just going to go with the one with the lower numbers. Either one will work. So x and y, don't forget that. Okay, y is 40, so it goes there. And x is 50, so it goes in the x spot, plus b. Does that look okay? 4 times 50 is 200. I'll bring down the b, equals 40. Now we have a basic equation here to solve. We solve by opposite operation. We always solve equations by opposite operation. So it's plus 200 minus 200 plus b. So it's plus 200, we subtract 200 from the right side, and we subtract 200 from the left side. The 200 and the minus 200, that cancels out. So we get b equal to 40 minus 200 is minus 160. That looks right to me. And then we write our final equation, y equals 4x minus 160. Now, if we were, it might make it a little bit easier if we were to write this using some letters from the problem itself. So what we could do is say that the chirps, C for chirps, is equal to 4 times the Fahrenheit temperature minus 160. And that just makes it a little bit easier to put the numbers in the right place when you use letters from the question. You don't have to, but sometimes you are asked to use letters from the question and then you have to do that. Okay, so the next part of the question says, what is the rate of chirping when the temperature is 83 degrees Fahrenheit? So we're going to start off with our equation. Always start with the equation. Can't go wrong. All right, so 83 degrees Fahrenheit. Where does the 83 go in here? What is the rate of chirping when the temperature is 83? Well, it tells us right here that 83 is F. So we're going to do 4 times 83 minus 160. See how easy it is when you use the letters from the question? Okay, so that's 332. 4 times 83 is 332, I think. Yes. And subtract 160. So the chirping rate when the temperature is 83 degrees Fahrenheit is, that works out to 172 chirps per minute. So you can see when that temperature goes up, these little critters are really active in their chirping. All right, so second question that goes along with finding the equation, C equals 4F minus 160. This time it asks us to find the temperature in Fahrenheit, so we're finding F. So I'm going to write down F, because that's what we have to find, minus 160. Now, where does this go? 56 degrees. No. Did I say that right? What is the temperature in Fahrenheit when the number of chirps per minute is 56? That shouldn't be 56 degrees. That should be 56. That's 56 chirps per minute. So 56 goes here, like so. So I had a degree sign beside the number of chirps. Just a careless error, but for 1 second there it threw me off. Okay, so here we have an equation again that we have to solve, and we solve by opposite operation, just like we did a few minutes ago when we found the B. This time it's 4F minus 160 plus 160. So you do the add subtract part first, and the opposite of subtract 160 is add 160. What we do to one side, we have to do to the other side, so we have to add 160 here. On the right-hand side, the negative 160 and plus 160 cancel out, so we have 4F equals, I think that's 216, and it is. And what we're left with here is 4 multiplied by F, solved by opposite operation. The opposite of multiplying by 4 is dividing by 4, and 216 divided by 4 is 54. So we have, I can put the degrees in there now because I know that's Fahrenheit. So there is my answer. When it's 54 degrees Fahrenheit, the chirping rate is 56 per minute. So you can see that as the temperature goes down, up here it was 83 and we had 172 chirps per minute. In this question it's 54 degrees and we have 56 chirps per minute. So when that temperature goes down, the insects are less active. Okay, I hope you found that not too difficult. Starting to get used to those linear models, those linear problems. Now, I want to talk to you about homework. In your book, page 372, page 373, I would like you to do 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. Now, if you need help, it's important to emphasize this. I want you to send me an email. Don't be embarrassed. Don't feel that you're bothering me. I'm doing this because I want to help you. I have students texting me all the time asking me questions. Now, one of the wonderful things that I've been able to do in the past number of days, I can now give, at this table where I'm sitting, live help. So if you have a question, we can be talking live and I can see your face on the computer, and you'll be able to see me writing out the solution or explaining the question that you're not understanding. So I'm pretty excited about that. As always, when you're working on your homework, be patient with yourself. Be kind to yourself. This is going to take a while to do because there's so many questions. So please don't rush through it. I know from my own experience, every time I sit down and do math, if I try to do it too fast, I make careless mistakes. Take your time and you'll be fine. That's today's lesson. Thank you very much. Have a great day.